Next, after finishing about bioethics, we are dealing with relation to biotechnology in relation to medicine, and we would be dwelling on the issue of the development of human insulin or humulin. Human insulin or genetically engineered insulin is termed as humulin. This comes under recombinant therapeuticals. A therapeutical is a sort of a compound which primarily is meant for curing a particular sort of a disease. So, how do you develop recombinant insulin or humulin? What exactly is the history? Just like how we dealt with relation to the sort of a golden rice as well as with relation to pest resistant nematodes, the third case study here in genetic engineering or biotechnology is with relation to development of humulin or genetically engineered insulin. In 1921, Banting, Best and MacLeod had primarily isolated the pure extract of insulin for the cure of diabetes from the pancreatic islets of dogs. So, this was the beginning wherein primarily you had the development of insulin. But however, whenever you produce this particular sort of an insulin, we understand insulin is produced only in very low quantities. Now, parallel to these particular sort of early discoveries, we have somewhere in the 1980s, that is after the development of the recombinant DNA, the first artificial recombinant DNA, if you recollect, in the case of PBR322, and we had been using restriction enzymes. L. Lilly, an American company, came out with a novel method. It's a new method which aimed at continuous supply of insulin, because when we use animal based insulin, the supply is very less. They aimed at continuous supply of insulin and for stabilizing the market price of insulin. So, they were responsible for the development of a sort of a recombinant insulin. Now, what exactly happens down here when you take up primarily with relation to therapeuticals? When you take therapeuticals, there are 30 approved worldwide therapeuticals which are present in the world. Approximately about some 30 approved worldwide, and 12 are marketed in India. 12 are marketed primarily in India. So, when we are looking in terms of therapeuticals, we are coming to the case of insulin. How do you develop a sort of a recombinant insulin? An insulin molecule is made up of 51 amino acids. It is made up of 2 polypeptides. Chain A is made up of 21 amino acids. Chain B is made up of 30 amino acids. And chain A and chain B are linked by means of disulfide bonds. The disulfide bond is very, very important, because only in the presence of a disulfide bond, then only you have a C peptide which is called a prohormone. The prohormone is an extra peptide. This extra peptide, when it is added to A and B, then only it makes a mature insulin. So, a mature insulin is made up of an A chain, it is made up of a B chain, and it is made up of a C peptide. So, when you have both the A and the B chains as well as the C peptide, then only you get a sort of a mature insulin. Now, primarily what did L. Lilly do? The L. Lilly company, which was responsible for recombinant insulin, they produced chain A and chain B separately in vitro, that is inside Escherichia coli. By using a sort of a plasmid, they could synthesize chain A and chain B. So, first one is they had separately produced chain A and chain B. Next, they could extract it out. They extracted chain A and chain B in vitro. And later on, they combined chain A and chain B, and they created a disulfide bond. So, when they created a disulfide bond, they could develop first genetically engineered human insulin, which is termed as humulin. So, L. Lilly primarily were responsible for preparation of the 2 DNA sequences. They could manipulate the sort of a DNA in the bacteria and prepare 2 DNA sequences. So after they prepared the 2 DNA sequences, they made the two DNA sequences was corresponding to the 2 chains of A and B in the case of insulin. Then they had taken both the sort of chains and introduced it into the plasmid of E. coli. So in this situation, especially with relation to the preparation of the artificial recombinant insulin, we understand that we had used bacteria, and the bacteria takes the foreign genes, hence the bacteria is termed as a transgenic bacteria. This is one example of how do you use a bacteria as a sort of a transgenic organism. So by manipulating they prepared 2 DNA sequences corresponding to A and B genes, and they placed it into the plasmid of the E. coli. And here within the E. coli, the insulin chains were produced. So what exactly are the advantages of recombinant insulin when compared to normal human insulin? The recombinant DNA insulin has got low allergy. It is low on allergy. It can be produced in very high quantities. It has got high purity, and it is ethically accepted. Because we don't slaughter pigs, it is ethically accepted. The speed of supply is very high, and its effectiveness on towards patients are also very, very high. So given the best of the situations, we understand this is a case wherein humulin for the treatment of diabetes is worldwide, and maybe we could cite humulin or recombinant insulin as the first very large success story of genetic engineering or biotechnology in the world. Imagine the number of diabetic patients in the world, and imagine the slaughtering of pigs and the slaughtering of other animals from the pancreas, from which we can get only limited quantity of insulin. Natural insulin causes a lot of allergies, and natural insulin is produced in small amounts. Natural insulin can easily be contaminated. It cannot be available in the pure state. So thereby to overcome that with lowered allergy, high quantity, more purity, encompassing and overcoming even ethical issues with better speed and better effectiveness, we always have the sort of a recombinant insulin molecule.